Welcome to Monkey Physics IIT JEE NEET Foundations.
Let's take one more example. So in the previous all examples, the object moving in a straight line. Now in this example, let us consider the object is moving in a curved track. Example, curved track means the track what we can remember is the object moving in a circle of radius r, this is the center of the circle. Now if the object starts from A, it's moving towards this track and at B, this is the B. Now again it is continuing its path, reaching to C and again reaching to D. This is what. Now in this case they are asking us, find distance and displacement. Distance and displacement for given paths. For given paths. What are those given paths we are mentioning here? It's a AB curved path and then ABC curved path and then ABCD curved path itself and again last one ABCDA. This is also curved path. Just for convention I am representing, it's a curved path. Now let's take first the curved path AB from here to here. Now we all know clearly it's a total angle it is making at the center is 2 pi. And the curved path AB, only this AB is making an angle pi by 2. So how do you consider the relation? What is it is existing? Not only in this case, general relation what it is? It's a total path by total angle is equal to selected path upon selected angle. Of course, please remember this kind of relation, it is going to help us in almost most of the topics and most of the chapters for the competitive exam, what we are talking about. Yeah. What is meant by total path? Total curved path I am talking. What is the total curved path of this circle? We all know the total curved path of the circle is nothing but the circumference, isn't it? What is the formula of circumference? It's a 2 pi r upon. What is the total angle it is making at the center of this total circle? 2 pi. Yeah, this must be equivalent to selected path. What is that selected path? AB, curved path. And what is that selected angle? Pi by 2. Isn't it? Now this selected path of AB is nothing but, 2 pi getting cancelled. It's a pi by 2 r. Of course, we all know this is nothing but the formula like arc length. Arc length is equivalent to radius into angle subtended at the center. Okay, radius into angle. What is this angle subtended by? Arc at the center. Subtended by arc at its center. Isn't it? So if you use this formula directly also you can get it. What is that? Arc length AB, radius r. What is the angle subtended at the center by this r? Pi by 2. So that is pi by 2 r. Yeah. Now let's come back to displacement. What about displacement? So to find out the displacement, we need to draw for the path we are talking about, isn't it? Yeah. So for the path AB bar, if they ask us the displacement, look at here, AB, path AB, displacement. Displacement is nothing but we have to draw a shortest strip line. We have to draw a shortest line. So when we draw, it is clear. What is this distance? R. What is this distance? R. Now it's like a right angle triangle. Now we can apply Pythagoras theorem, isn't it? It is going to become root 2r. Therefore, the displacement for the path AB is nothing but root 2r. Root 2r. Now if they extend the question in this only, what is the ratio of distance to displacement for the path AB? If they ask us, it's a notation only I am following, nothing else is there, isn't it? So ratio of distance to displacement for the path AB I am talking about. So for the path AB, what is the distance? It's a pi by 2r upon, for the path AB, what is the displacement? Root 2r. So what is the ratio we can give it as? It's pi by 2 root 2. Isn't it? It is going to give you pi is to 2 root 2 is the ratio of distance to displacement for the path AB bar. Now coming back to the second one, I am going to take a ABC path for path ABC distance I am talking. So the same, now we can use this formula directly, isn't it? Same method, but I'm not going to do the method again. So same method you follow, and otherwise you can apply this relation. What is that? Radius into what is that angle subtended by ABC? ABC, this is subtending an angle of 180 degrees. It's a pi at the center, isn't it? It's a pi. And other way also we can see, we know the circumference of the circle is 2 pi r. And it is half of the circle we are taking, semicircle, isn't it? What is half of the circumference? 2 pi r by 2 is nothing but pi r. So that itself is a distance, pi r. And what about the displacement? Displacement, shortest path, na? Any guess? From here to here. We need to draw a straight line from here to here. I hope by this time you come to know, isn't it? Yeah, what is that? It's a 2r. Now again, if as is the ratio to distance to displacement for the path ABC, we are taking it. So what happened to this? It's a pi r upon 2r is nothing but pi is to 2. What is the ratio? Pi r upon 2r is nothing but pi is to 2. Isn't it? Yeah. So in the same way, we can do for even ABCD. Now what is the total angle subtending? 3 pi by 2, pi by 2, pi by 2, pi by 2, 3 pi by 2 angle. And what is the radius r? So 3 pi by 2 r. So for this case, I am writing it directly here. It's a theta 3 pi by 2 and r. So this is the answer, distance. And what about displacement? Displacement is, of course, this is how we are drawing. So same as like this, magnitude y. So it's a root 2r. Now we can calculate even ratio of a distance to displacement. And that remaining part of the small calculation, I am leaving it to you. Is it clear? And what about for this? For this, the object is starting from A, moving towards B, C, D, A. So what happened to the displacement? Displacement, it's coming. What is the distance it moved? Distance it moved is equivalent to 2 pi r. And displacement is nothing but 0. So here displacement is 0.